Hey everybody, my name is Brandon Hancock, and in today's video I'm going to show you how to create an automated DM Twitter bot so that you can start growing your Twitter following or start a profitable software business. By the end of this tutorial, your Twitter bot is going to be able to create customized graphics and automatically DM these graphics to people who follow you. So here's how it all works. We're actually going to DM people a customized picture of their tweet history that looks something just like this. And the way we're going to do that is if they send a special hashtag, in my case, hashtag Brandon Hancock, we're going to automatically DM them a picture of their tweet history. So here's an example of what a tweet history would look like for one of my friends named Kyle. But yeah, that's what we're going to be building. And there's a lot of magic that's happening in between our people sending us a special hashtag message to sending this picture back. And that's what the rest of this tutorial is going to show you. So let's go ahead and dive back in. So if you're a beginner or intermediate developer who's looking to take on a new challenge and dive in a little bit more to backend development, this is the tutorial for you. So before we start coding, I want to let you know that this video is broken up into 4 different parts. In part 1, we're going to be covering the high-level problem that we're solving. In part 2, we're going to map out the solution that we're creating. In part 3, we're going to set up all of your AWS and Twitter accounts, so we're prepared for the rest of the tutorial. And in part 4, we're going to start coding. So if any of these parts interest you more than the others, feel free to use the timestamps below to hop around. But yeah, let's go ahead and start diving into the problem that we're going to be solving. All right, so let's dive into the problem we're trying to solve. Growing on Twitter is a lot harder than I thought it was going to be. Over the course of about a month and a half, I've gone from 19 followers all the way up to about 270 followers, but this has taken a bunch of work. So what I wanted to do was figure out some sort of way to go viral, and here's what I actually noticed. If you took a screenshot of your GitHub commit history and posted on Twitter, it appeared that you would just magically go viral. For example, this guy named Tony, he took a picture of his GitHub commit history and he got 500,000 views, a bunch of likes, and I'm sure he got a ton of followers. So I wanted a slice of the pie, and this led me to come up with my unique solution that I thought would explode my Twitter as well. So what I ended up doing was repurposing these GitHub commit charts and applying them to our users' tweets. So here's an example of actually what we're going to be making. As you can see, this looks just like a person's GitHub commit history, except this is their tweet commit history. It's the same principle. It's remixed though, so I had the idea that I thought this might go viral. Now that we know what we're making, let's go ahead and actually dive into creating a flow map so we can see how it all fits together. Before we get started on that, if you're excited about this tutorial so far, it would be a huge help if you could drop down and hit that like and subscribe button so you could see more content just like this in the future. All right, back to it. To make visualizing this solution easier, what I've done is I've created a flowchart here in Excalibur. If you haven't used this tool before, I would 100% recommend checking it out. All right, so let's start at the top and work our way to the end. To start off, we need some way to listen to tweets that come from Twitter. Thankfully, Twitter has a streaming service that allows us to receive tweets in real time. Now that we know that we can set up Twitter to send us tweets, we need some way to receive it. So we'll need to create some sort of tweet listener. Each time our tweet listener receives a tweet, we need to verify that the person who created the tweet is actually following us. If the user is following our account, we want to reach out to the Twitter API and pull down their most recent tweets. Once we pull down the user's tweets, we need to start counting how many tweets they made per day during a year. Once we know how many tweets a user is making per day, we need to visualize this data in a Twitter heat map, similar to what you've seen on GitHub. Finally, we need to take a screenshot of this heat map and then send it out to the user who it belongs to. Now that we've made a simple flow diagram, what we need to do next is map each one of these tasks to an AWS service. In our case, there's going to be 5 different AWS services that we need to use. We're going to use Lambda functions, EC2 instances, simple queue services, we're going to use S3 buckets, and we're also going to use DynamoDB. So let's look at a brief overview of each one of these services. The main AWS service that we're going to be using for this project are AWS Lambda functions. And simply put, a Lambda function is just a chunk of code that you can run in the cloud without having to worry about setting up your backend, infrastructure, and all of that. A lot of developers use them because they're pretty flexible and pretty cheap, and they can scale infinitely. So let's move on to the next service. The next AWS service that we're going to use are EC2 instances, which stand for Elastic Cloud Compute Instances, and these are basically virtual servers that run in the cloud that we can control. Additionally, we'll be using the AWS SQS service, which stands for Simple Queue Service. So think of a traditional queue where it's first in, first out, and we'll mostly be using this service to connect different Lambda functions together. The next AWS service that we're going to use is DynamoDB. This is basically a NoSQL database database that we're going to store a lot of our temporary data. The last AWS service that we're going to use is Amazon S3, which stands for Simple Storage Service, and this is the service we're going to use to store most of the pictures that we create for our users. Wait, there's actually one more service that we're going to use. It's the Amazon API Gateway, and we're going to use it to, guess what? Create APIs. So now that you know all the different services that we're going to use from Amazon, well, it's time to go ahead and convert our simple flowchart over to an Amazon API service flowchart. So let's go ahead and get started. The first thing that we're going to do is map our tweet server to an EC2 server instance. The reason we want to map it to a server is because we need to have something that's constantly running and listening to the tweets that are produced by the Twitter Stream API. Because this server is disconnected from the rest of our Lambda functions, what we need to do is pass the new tweets that our server collects to an API gateway so that the tweet can be passed along to the rest of our backend. In order for our API gateway to work properly, we will map any post request to the API tweets endpoint to the follow verifier Lambda function. Each time this Lambda function receives a new tweet, it'll reach out to the Twitter API to verify that this person is following us. And if they are, we will pass this tweet along to our simple queue service so that it can be processed by the next Lambda function. In this case, the next Lambda function is going to be the tweet aggregator Lambda function, whose whole purpose is to pull down tweets for this specific user. After this aggregator function runs, we'll pass all the tweets we collected to the next simple queue service, which relays all the collected tweets to the tweet data processing Lambda function, whose whole purpose is to count the number of tweets a user makes per day. Once this function counts the number of tweets a user has made per day, it will save the results to a DynamoDB table. The reason we save the results is because we have a website whose whole purpose is to load a visual representation of the saved tweets. So we create a DynamoDB stream that listens for new items that were created in the database, and we pass these new items along to another Lambda function. In this case, we're passing it along to the screen request Lambda function, whose whole purpose is to pull out the author ID and the record ID and pass it along to the API gateway. Each time a request is made to this API Gateway Endpoint, it calls the tweet screenshot Lambda function. The purpose of this screenshot Lambda function is to use Selenium to load a unique website that we create, wait for the data to load on the website, take a screenshot of that image, and then upload that image to an S3 bucket. Once that image is uploaded to the S3 bucket, it will trigger an event that fires the next Lambda function. In this case, that means we will be DMing our end user with the picture we just created. If anything's been confusing so far, don't worry, just drop a comment down below or shoot me a DM on Twitter and I'd be happy to help out. All right, let's hop back to it. Okay, so we're about to start building all these different services out in the cloud to make our bot work. But before we do that, I just want to let you know that if you came here to learn how to make a simple Twitter DM responder, you can actually just go ahead and copy the specific squares down here. So as you can see, you'll need to learn how to copy the Twitter stream, make an EC2 instance, set up the API gateway, and set up a Lambda function. So if you just hop around to those 4 different steps, you'll know how to do everything, and you can actually skip out on a lot of the fancy in-between steps. Okay, so let's go ahead and just start building each one of these services out. Since our bot is going to be running in the cloud, what we need to do is set up an AWS account. All you need to do is head over to aws.amazon.com to get started. Once you're over here, just go ahead and click create an AWS account. When you're in there, you go ahead and type in your email that you want to use. I'm just going to type in mine real fast, .io, and then just come up with whatever account name you want to have. Once you do that, what will happen is you'll get an email sent over to your account, and then from there you might have to do a few other verification checks, and then from that point forward you should be good to go. And just to also let you know, everything that we're going to be doing should stay under the free tier. After you verify your Amazon account, you should see a screen very familiar to this, where you can click on services and see all the different Amazon services. In addition to setting up our AWS account, we also need to set up our Twitter developer account. The best way to do that is to head over to developer.twitter.com. You need to log in with your Twitter account, and after that, you're going to want to hit that developer portal button. So what you're looking at right now is a blank account that I just set up, and you can see that it's asking us to fill out some additional information, so I'm going to do this. If you already have a developer account, you can go ahead and skip all of this. But I'm just going to say making a bot. No. Let's do this. What you'll need to do next is read through this agreement policy, go all the way down and press the accept terms, press submit. Then Twitter is going to send you an email to verify that your developer application is going through. So what you want to go ahead and do is head over to your email account and press accept. Once you press accept on your confirmation email, what you'll need to do is come back to your Twitter developer account and start filling out the rest of the form. So we're going to go ahead and do that right now. The first question that we need to ask is, what is your current coding level? Feel free to just pick any of them. Then you hit next. So on this screen, what we'll do is type in our intended use for how we want to use the application. So I'll go ahead and copy and paste what I'm putting in here into the YouTube description video, so you can feel free to copy and paste it. Now that we filled out that section, we actually need to move on and fill out the rest of them. As you can see, there's a few more that we need to do, so I'm going to speed through this really quickly. Feel free and copy and paste the answers that I provide in the YouTube description below. Cool, now that we fill out those sections, what we can do is go ahead and hit next. On this page, it's letting us review our basic information and our intended use. We'll go ahead and hit next again. And finally, we need to accept the terms and policies that they've put forth. All right, cool, we just submitted our application, so now they're going to send us an email and let us know if they need anything else from us on our end. Since I just made this Twitter account, it's actually not going to give me access immediately to the features we need. So what I've done is hop back over to my normal Twitter developer account so we can continue this project. So if it looks a little bit different, that's why. So right now we're back in our Twitter developer dashboard, and yours might look a little bit different since you don't have any projects created yet. So one of the first things that you're going to want to do is to create a new project. I think there should just be a create new project button here for you on your page, and instead of being at the elevated access level, it'll start out at the essential level. What's super nice though is that all you have to do is, I believe in the project setting, just request to go to elevated access and do a quick sentence or two and explain why you need to receive this elevated access, and you're pretty much immediately granted it. So once you create your project and potentially asked for elevated status, the next thing we need to do is start to create our new apps. So that's what we're going to do right now. In order to do that, what you're going to want to do is head over to this projects and app tab and go down to the overview section. Once you're there, you'll see a little button that says add app. So that's what we're going to go ahead and click on. As you can see, the next button is grayed out. So what we're going to need to do is click the production app, because that's what we're going to want to make, a production app. We'll give it a unique name. In our case, I'm going to call mine Twitter commit YouTube, since I already have an existing app. And then lastly, it's going to generate your keys and tokens. I'd go ahead and copy and paste these keys and tokens over into a notepad or somewhere safe, and where you can store them and add them to your environment variables later. But yeah, you don't want to be publishing these on GitHub or anywhere else that's pretty publicly accessible. So after that, what we're going to do is hit go to dashboard. But yeah, that's pretty cool. We just created our new app, and you can see it right here. If I hit the settings button, I can go ahead and see our app. I can go back and look at our keys and tokens. So yeah, that's everything you need to see. So now we're going to hop back over to actually start coding. I'm excited. To prevent you from having to code everything from scratch, I went ahead and linked my GitHub account down in the YouTube description below. So the main thing that you're going to need to do is clone this repository to somewhere locally on your computer. In order to do that, the best thing to do is go over to the GitHub link, press code. We're going to copy this link right here. What we're going to do next is head over to a new terminal and then head over to a directory where we want to copy this new code. In this case, I have a little folder already made, so we're going to type in git clone and then the URL, and this is going to take a few seconds to pull down the repo. In my case, I'm going to go ahead and cd into this new directory, and I'm going to open it up in my Visual Studio Code editor. Let's go ahead and get this full screen real fast. All right, cool. So now let me walk you through this new repo, okay? As you can see, there are 3 different folders in this repository. The first folder is our Lambda folder, which stores all of our Lambda functions. The next one is our tweet commit graph, which actually is a website that we're going to use to show and load how many times a user tweets per day. And the last one is our Twitter stream consumer. This is going to be the application that's running on our server to listen for tweets that get sent to us from the Twitter API. In order for us to go ahead and set up our Twitter API to listen to specific tweets, what we need to do is head down to this rules.js file. So here's why this rules.js file is so important. As you can see from the Twitter documentation, we're trying to create a filtered stream. And in order to create a filtered stream, we have to build rules that specify what events and messages that we want to listen to. So heading back to our rules.js file, you can see that we have a create rule function. And what this does is it sends a rule that we make to a specific URL. In our case, this is going to be our API-Twitter.com tweets streams rules. This was the same thing that was just shown in the documentation. We're also going to pass a bearer token. This is the same bearer token that we got initially from our API keys when we were creating our application. You can head back to the Twitter developer platform if you have lost that bearer token and regenerate it. But what I've done to make this easy for you is down at the bottom of your rules.js file, I've created a variable for you that already includes an example rule. In this case, it says Brandon Hancock. We're going to change it to Brandon Hancock test, save it. Then as you can see, this variable gets passed into the function that I was just showing earlier. To run this, all you need to do is open up a terminal, change directories into our proper folder. So in our case, Twitter stream consumer. And as you can see, we have our rules.js right there. But before we run it, what we need to do is install all of our dependencies. This might take a few seconds. After that, what happens if you actually run node.rules, you're going to get an error. And the reason why you're going to get an error is because we have not actually defined our environment variables yet. If you look, I have an environment variables example file. So what we'll need to do is duplicate this file right here, paste it, get rid of this real fast, and we're actually going to rename it to just .env. And if we look in our .getignore file, you'll notice that we've added this .env explicit instruction right here, which means we will never add this file to our GitHub repository, which is important because we do not want to be storing our secret information publicly for everyone to look at. All right, so let's go ahead and copy and paste those example API keys over into this file. In hindsight, the only variable that you actually need is your bearer token, so I'm going to go ahead and paste that in here and delete the rest of them. We'll save our file, and now we'll rerun our command. Let's go down here, press up, run our command, and then you can see we get back something. You can see it created our new rule, gave it an ID, and let us know we sent it, and that it was created. So that's awesome. So now what we can do is head back to our rules.js file, and actually just to double check that it works, what we'll do is comment out our create rule and uncomment out get rule, save the file, run it again. And fantastic. You might only have one item just because we only created one item for you, but since this is my main account, it already has my initial tweet stream rule, so you can ignore that. Now that we've submitted our rules to the Twitter API, our stream should be set up. So what I've done is created a server to listen to events from this Twitter stream. So let's go ahead and hop over to the server and I'll walk you through everything. All right, there's two files that you need to be aware of for us to listen to our Twitter stream data. The first one is this index.js file and the other one is this stream.js file inside of the Twitter stream consumer. So before diving into these two files, I just want to give you a quick recap of the whole point of these files. Basically what we want to do is listen to data coming from the Twitter stream, capture that data, and then send it off to our backend so we can start working with the data. And here's how all of that works. All right, so here's the most important parts of these two files. First off, we create an event emitter with the whole purpose of passing this over to our stream tweets function, as you can see right over here on the right. The reason we want to do this is because we want to allow this function to let us know when it receives data, such as a new tweet, or whenever it receives an error. If it receives a data, aka a tweet, what we want to do is send this tweet off to our backend so we can start processing it and handling it how we want. However, if we receive an error or if something goes wrong, what we want to do is reconnect. If any of that was confusing, don't worry. Most of this code was copied from the Twitter developer documentation and I've provided a link to it at the top of the file. But now that you've seen how everything kind of fits together at a high level, let's actually try testing it out. And the easiest way to test it out is to actually open up your terminal. We want to change directories to the file where our index.js file is at. Just double check that it's here. Yep, it's here. And then if we run node index.js, what it's going to start doing is listening for tweets that have our special hashtag. In our case, we're going to listen for the hashtag Brandon Hancock because that's the rules I set up. So let's head over to Twitter real fast. The way that these streams work is it'll let you know if someone created a tweet or a reply with your special rule inside of it. So in our case, to test it out, I'm going to head over to my Twitter channel, go down to my pinned tweet, and I'm actually just going to reply with Brandon Hancock in it to test it out. Okay, so what'll happen, I'll hit reply. Then what we're going to do is head back over to our code. And what you'll see right now is it's been saying Twitter heartbeat, but in a few seconds, our stream should send us the new tweet that I just created. All right, it took a few seconds, but my tweet actually went through and it captured it here. So congrats, everything's working, so now we can move on to the next step. In our case, what we want to do next is deploy our local code to an EC2 server in the cloud. And the reason we want to do that is so that our code can continuously run even if our computer is not on. So let me show you how to do that real fast. As I mentioned previously, all the code for this tutorial is on GitHub, so you actually don't need to worry about pushing any code to the cloud right now. Instead, what we'll do is set up our Amazon EC2 instance to pull from this GitHub repo. But if you end up doing something differently, what you'll want to do is point to not this GitHub repo, but your own. Okay, cool. So next what we want to do is head over to our Amazon cloud. If you haven't already logged in, you need to go ahead and do that right now. What you'll want to do next is head over to the EC2 instances. So you'll just type in EC2 up in the search bar and click EC2. So what we're going to want to do on this page is to actually create a new instance. So you'll probably see a button that looks just like launch instance right here. If not, you can head over to instances over here and once again just hit launch instance. Once the page finishes loading, we're going to go ahead and populate it with all the information to create our instance. The first thing we're going to need to do is to set up a unique name for this instance. So in our case, I'm going to call it Twitter Stream Consumer Test. The reason I'm calling it test is because I already have an instance. Feel free to give it whatever name you'd like. Next, we need to select the operating system. In our case, I'm going to use Ubuntu because I've had the best luck with it. So keep scrolling down, we need to select the instance type. This basically tells Amazon how big of a server that you want to rent. In our case, we're going to stick to T2 Micro, and the main reason we're going to do that is because it's free, and I've had zero problems with it so far. Next, we're going to scroll down and select the key pair. In our case, we don't really need it, so I'm just going to say none, even though it's not recommended. When it comes to security groups, we're also just going to create a new security group and keep scrolling. Once we get to the bottom of the page, we need to open up the advanced details section and scroll all the way down to the user data section. The user data section is an area where you can put in some code that you would like to run when this instance is created for the first time. In our case, I've actually made a script for you that's in your GitHub, so let's head over to there real fast. All right, so here we go, over to GitHub. We're gonna hit our Twitter Stream Consumer, then we're gonna open up our scripts folder. And then inside of that, I made a userdata.sh file for you. So what you're going to want to do next is hit this copy button. And what we're going to do is paste it back over to our user data field over here. And now let me give you a quick rundown of what this file actually does. So there are three major parts to this code. The first one is to create a local script that allows us to install our node version manager. And the reason we're making a script within a script, it's a little complicated, but the reason why is because user data is automatically ran by the administrator. But in our case, whenever we log into our AWS server, we're logging in under the local non-admin Ubuntu account. So we're doing some magic here, but once we create the script, we can install it under the proper user. In our case, as I mentioned earlier, we want to install it under that Ubuntu user. And then finally, what we're going to do is set up a service. And if you're not familiar with Linux services, basically they're just background tasks that run behind the scenes and do some work. So in our case, if you want to learn more about this service, you can click over here and see that we're basically always going to have it to where our service automatically restarts and pretty much always runs. Okay, cool. So now that you know how our user data file works, let's actually finish spinning up our server and then testing it out. So I just hopped back over to AWS, and now that we've loaded in all of the proper fields, we can go ahead and launch our instance. This should take a few seconds to load, but once it does, we have two last steps that we need to complete. So let's go ahead and click on our newly launched instance. As you can see, it's in the pending state, so we need to click that refresh button a few times and wait for it to actually start. Cool, so it's running now. It took about a minute to spin up, but what we can do is click this button here to actually look at our instance details. And if we want to connect to our instance, we just hit connect. So what we're gonna do is leave everything how it is and just press connect. And what this is gonna do is actually run a SSH instance to our cloud server. After it finishes booting, we wanna run two separate tasks so that we can begin to test our server to make sure everything's working properly. The first task that we wanna do is actually copy over our environment variable that we made on our local file over to our cloud computer. So let's go ahead and do that first. So in my case, I'm going to swipe back over to our Visual Studio Code instance, go back to our folder, click my .env file. I'm going to copy all of the contents, come back over to my AWS instance. Next, I'm going to change directory to our new folders. In our case, everything was created under the tweet commit DM bot. Then I'll go into our Twitter Stream Consumer folder. And as you can see, this looks exactly like our local file structure, except we need to create our environment variable. So the way to do that is to do nano.env, and this will create a new text editor for us. But all we have to do is just click paste, and it'll copy over our bearer token. I'm gonna do Control X to exit out of this. I'm gonna save my changes. And fantastic, we've loaded our environment variables, and that leaves us with one last task, which is to restart the service we created with our user data script. So all we need to do is type in sudo systemctl start Twitter stream consumer.service. All right, cool. Now to check that it's working, what we can do is press up and change it from start to status to see what the status of this service is. In our case, it has a quick error, but let's fix that real fast. Okay, so I found the issue, and it actually comes down to a quick issue with Node. In my code, I'm referring to using the latest support version of Node, and that actually changes dynamically, but in our code, we hard code it. So let me show you real fast. The first thing we need to do is change directory to our Node version manager and actually look to see what version of Node we're using. So what we'll do next is hit ls to see that we're actually using 18.14.1, but in our service file, we've had a hard-coded version number of 18.13. It didn't seem like that. We'll actually follow its suggestion, which will be sudo systemctl daemon reload, run that. Okay, now let's update and check in on our status of this file. And you can see that it's running now. Now it should take a few seconds for it to actually start listing logs. So the easiest way to recheck to make sure that it's fully working is to press up a few times, and eventually you'll see that it's gonna have a Twitter heartbeat, just like this. So congrats, what it's doing right now is listening to our Twitter stream setup. This is pretty cool, but the best part is we can now move on to the next step. So here's where we're at so far. We set up some rules to enable our Twitter stream, and we hooked up our Twitter stream to our EC2 instance that we just created. Next, we need to create our API Gateway Endpoint. And the reason we want to do that is because we want to pass the tweets that we collect from our server to the rest of our backend. And the API Gateway is the easiest way to do that, so let's go ahead and start creating it. All right, we're back over to our AWS account. The easiest way to find our API Gateway is just to hop up here to the top and type in API Gateway, and it should be one of the first options that pops up. All right, so once the page loads, what we want to do is to create a new API. Yours won't look like this because it'll probably be empty. I've already have this API set up, so what we're going to do is create a new one from scratch for you. So in order to do that, we're going to hit the Create API. We're going to scroll down, and we want to make a REST API. More specifically, we don't want to make the private one, we want to make a public one. So I'm going to click Build. Next, we need to choose a few different configurations. We're going to stick to keeping this a REST API, and we want to make this a new API. So I'm just going to call this one tweet commit to, since I already have an existing one. Skip the description, keep it as regional, and then press create. Once it's done creating, it should bring you to a screen that looks just like this. And there's a few key things that we need to do in order to create our API. The first thing we got to do is to click this actions button right here and to create a resource. If you're familiar with backend development at all, you'll notice most of the time you'll reach out to an endpoint such as API/tweets or users or payments, something. In our case, that's going to be the resource. And since we want to pass tweets from our server to the rest of our backend, we're going to call this resource name tweets. We're going to keep the resource path tweets as well. And then we're going to press create. And as I just mentioned a few seconds ago, we want to pass tweets from our server to our backend. So the easiest way to do that is through a post command. So what we'll do is hit tweets, then we'll hit create method on top of this resource, and we'll select which method we'd like to use. In our case, we're going to do a post method, and then we're going to press accept. Now it's asking us how we would like to integrate the method we just created. In our case, we actually would like to use a Lambda function. However, we haven't created any Lambda functions yet, so we'll need to go ahead and do that. The easiest way is just to type in Lambda up here. I'm going to go ahead and open this in a new tab. Open it, and then after it loads, it should bring you to a screen that looks just like this, except yours will be empty, whereas mine's pretty full. All right, so what we need to do next is hit create function. And this is where we'll actually provide all the details for our Lambda function, which will then be integrated with our API gateway. And if we just swing back to our initial drawing that we created earlier, the first Lambda function that we want to create is our follow verifier Lambda function. So let's go ahead and make that right now from scratch. So I'm going to just call mine tweet commit, just to help me group my Lambda functions together. And then I'm going to call this one follow verifier. Next, we get to pick the runtime. In our case, we do want to use Node. And then other than that, when it comes to default execution role, we do want to make a new execution role per Lambda function. Now we should be able to press create function to finish creating our Lambda function. And this might take a few seconds to create, but once it does, you should get a screen that looks just like this. And now that's created, we can go back to our API gateway and finish building that out. So I'm going to go down here, and if I start typing it in, so tweet commit follow verifier 2, I'm actually gonna have to refresh it real fast because it didn't fully pick it up. This is an old Lambda function I made. But now whenever I type into it, I can see it right here, press enter, and it'll gladly connect. So now I can press save. It's gonna ask if it's okay to give permission for the API gateway to communicate with this Lambda function, and we do want to allow that to happen, so I'm gonna press okay. And once it finishes loading, you should see a screen that looks just like this. All right, congrats. You just made your API gateway. You've set up an endpoint for tweets, and you've allowed it to where we can start posting to it. In order for us to start testing it, we actually need to deploy it. To do that, you can press this actions button, and we're just going to click Deploy API. In our case, I'm going to go ahead and make a new deployment stage called Development, because that's what we want to do, is just try it out. Type in Development again, and then press Deploy. All right, now that I finished creating this new stage, what you can see is there's actually a URL that we can start sending a request to test everything out. In order for us to start testing our backend, we need to use a quick tool to send post requests. What I found is the best tool to do this is Postman. So what we'll do is hop back to the code and I'll show you how to start using this tool. In order for you to download Postman, all you need to do is head over to their website at postman.com and then just hit the download button right here for whatever operating system you're using. Once you've downloaded the application and opened it, you should see something pretty similar to this. Inside of this window, what you'll be able to do is start sending post requests, GET requests, or whatever you would like to do to any backend server that you've set up. In our case, we would like to start sending backend requests to the new API gateway that we just deployed. In order to do that, what we'll do is click Create a New Collection, and then we're going to rename this collection right here to Tweet Commit YouTube, since I'm making this for YouTube. And then inside of this folder, I'm going to click Add Request. And now we have to head back over to AWS to get the URL for our API gateway. Go back over here to our API gateway, and you can see our invoke URL is right here. So I'm going to copy this real fast. Just copy, and then bring it back over to Postman. And as you saw earlier, when we were setting up our API gateway, we made it to where we can send a post request to /tweets. So let's go ahead and test this out. Look, it's working. What you might notice is down here, we get a status code 200, which means everything worked properly. And then you'll notice that it has a body from Hello Lambda. The reason we're getting this response is actually because the initial template Lambda function that we use said to do this. Let me show you this real fast by heading back over to AWS. Let's go over to our tweet commit to follow verifier Lambda function. And if you scroll down to the code, it says to return a status code 200 and to return a body with a message of Hello Lambda. So yeah, so now everything's working. We're sending requests to our API gateway. Our API gateway is pinging our Lambda function and it's returning something back to us. So congrats, you're basically a full-blown backend developer now. So let's move on to filling out the rest of the code for this Lambda function. And before we do that, I want to show you our quick flow diagram one more time just so you can understand the code we're about to see. The entire purpose of the follower verifier Lambda function is to let us know if a person is following us or not. The way we're going to check to see if they're following us is to actually reach out to the Twitter API with a user who's sent a message to us. We're going to pull down all of their followers and check to see if our user ID is a part of their follower list. If it is, great, we're going to move on to the next step. If not, we're just going to kill the function right there so we don't continue to waste API calls to Twitter. All right, now that you understand everything at a high level, let's hop over to the code real fast. So what you're looking at right now is the code for our Twitter follower verification Lambda function. You can find it by looking inside the Lambda folder and then heading down to the Twitter follower verifier folder and then looking at the index.mjs file. So let's start at the top and work our way down. At the top, we're going to import all of our necessary libraries like our .env config so we can access our environment variables and Axios so we can start making requests to our Twitter API. And we're also going to import our SQS for simple queuing service, but we'll talk about that more in a minute. Next, we're going to start doing some configuration on Axios to reach out to the proper location on Twitter with a proper authorization code. This is probably a good time to mention that you need to recreate a new environment variable folder. The easiest way to create your environment variable file is to right-click on this folder, click New File, type in env, and then you're going to want to copy two things. You're going to want to copy your Twitter bearer token, which is the same one as beforehand, and then you're going to want to copy your Twitter user ID. Let me show you how you find your Twitter user ID real fast. What you're going to want to do is head back over to Postman, and once you're here, you're going to want to create a new request. So let's do that real quick by right-clicking and then hit Add Request. In this URL, you're going to want to paste this command right here, which says, I want you to do a GET request to API-Twitter.com version 2 of the API. And I want to get the user by username, and then we're going to use a variable. In our case, I'm just going to use my Twitter handle real fast, so be Hancock-IO. And if you just send it how it is right now, it's going to come back with an unauthorized request. So what you're going to need to do is head over to this authorization tab, click it, and then for type, you're going to do bearer token. And then mine's already pre-filled with the bearer token that you see over here. So now when I resend it, what it'll do is send me back my Twitter ID. So what you're going to want to do is go over here, double click it, and copy your ID, come back over to your new environment variable file, and paste it right here. But like I said, mine's already the same. Okay, let's head back to the code. So I think the best way to look at this is to continue going down the list. What you'll see inside of every Lambda function is one main function that gets exported, so the Lambda function knows how to route traffic to it. In our case, this is the handler function, which we're going to say accept a tweet. Now this is JavaScript, not TypeScript, so we can't do a lot of the fancy type checking. So what we're gonna have to do is some of the validation ourselves, which is why on line 14, we're saying, is this a valid tweet? So if we click this, what you'll see is I'm checking to make sure it has all the right properties. And we could probably do some more fancy checking, but we'll save that for later. If it is not a valid tweet, what we're going to do is return a status code saying of 400 saying that this is an invalid tweet. But if it is a valid tweet, we're going to keep on trucking. In our case, what we're going to do is pull out the author ID. And originally we were going to pull out the text so we can say like, hey, I want to check that this person said request chart or some other form of validation to really show that this user did want to receive a DM from us. Next, I have a little comment saying remove for testing. Basically, if you just want to test this function, you could comment all of this out and it would automatically send a message to SQS. But since we're not testing right now, it's okay to leave it how it is. And as I mentioned earlier in the overview section, the way that we're checking to see if this person is following us or not is we pull all of their followers down and see if our user ID is a part of their list. So let's look at this function real quick. Okay, now there's a few steps to this function, so let's go part by part so it all makes sense. In order for us to check to see if this person's following us or not, what we have to do is make a bunch of requests to the Twitter API to see if this person's following us. And the reason why I say a bunch of requests is because some users can have up to a few thousand followers, and we need to check through each one of them one by one to see if we're on the list. And the reason why we say 1,000 is because that's the maximum that Twitter allows us to make per request. And afterwards we have this pagination token, and the reason we put this here is because if a user has 3,000 followers and we're only allowed to get 1,000 at a time, this pagination token will give us a cursor back to help us figure out if we're at their first 1,000, second 1,000, or third 1,000. Next, what we do is check the response that we get from this API call. In our case, we're trying to make sure that we actually got back some data. And what we're also doing is checking to make sure that we got back an array. If both of those statements are true, we're going to update our total followers to include the followers that we just fetched from the Twitter API. And we're also going to look inside the Twitter metadata that was given back to us in our API call response and get the next token. This next token actually goes back to the pagination token that I was talking about earlier to help us keep track of where we are when searching through this user's followers. If we ever get to the point where there's no longer a next token, that means that we've searched through all of this user's followers and we can stop iterating through our while loop and know that we're done. And once this while loop is done, what it'll do is return our followers array. So let's go back to our original code real fast. And as you can see, this is where we will be returning our followers into this variable right here. What we'll do next is a little bit more validation just to make sure that we got back some actual followers. If for whatever reason this person didn't have any followers, we'll just go ahead and send back another status code of 400 saying, hey, something went wrong. And after that, what we're going to do is actually check to see if our username and user ID was a part of that list of followers that we just collected. If our name's not on the list, what we're going to do is once again return another status code saying something went wrong, and the function is going to stop executing and we're no longer going to pass through the flow diagram that we created earlier. However, if that did work, what we're going to do is head over to this part of the code where we submit this person to our queue so it can be processed by the remainder of our functions. And if you're newer to the simple queue service, don't worry, we're going to go into more detail into it in the next section. But for now, all you need to know is what we're doing is packaging up a message that we're going to pass from our Lambda function to the simple queue service, where there's going to be following functions that are listening. The other important part that you can skip right now is this queue URL. This doesn't exist because we haven't made your queue yet. But for example's sake, just pretend it did. What's happening is we're setting up our parameters using the Amazon SQS client and sending a command to our queue. If it works, great, we're going to return a status code of 200. If something goes wrong, we're going to return a status code to show that it didn't work. Now that you know how the code works, I actually want to talk to you about deploying our code. And it's a little bit tricky, but I've made it easier for you. Inside of your package.json file, you'll notice that I created two separate commands for you inside of this script section. The first one is zip, and the second one is deploy. The reason that we have to zip our files is because we have packages and dependencies that we want to deploy to the cloud. If we were just writing a simple function that only had an index file, we could skip this step and actually just copy and paste our code to the cloud. The next step is we actually want to deploy our code using the Amazon CLI. And the important parts of this function are the function name, and this is the name of the Lambda function that you created earlier. And the other part to it is this file zip that we made earlier. You'll notice that the name of the zip file, the name of the function, and the name that we're pointing to here are all the same. The zip files names can change. The only one that's actually very important is the name of the Lambda function that we created in the cloud. If it doesn't match, it's not going to work. But before you can run this deploy command, you actually need to log into the Amazon CLI. So I'm going to show you how to do that real fast. First, we need to download the Amazon AWS CLI. And the easiest way to do that is to head over to Amazon's page that gives you step-by-step instructions on how to do this. I'll provide a link to this in the description down below. But once you're on this page, what you'll do is scroll down to the setup instructions that apply to your operating system. In my case, I'm on a Mac, so what I would normally do is scroll down to the GUI installer, and then it tells me that I want to download this package, and then I'm going to be able to run some commands at the very end to verify that the AWS CLI was installed properly. Since I've already installed everything, I'm going to skip these steps, but just to show you that AWS is installed, I'm going to head back over to Visual Studio to run these commands. So what I'm going to do is open up a terminal and type in which AWS to see where this CLI is installed at. And then if I type in the AWS -- version, it should show me what CLI version I'm installed. Okay, cool. So everything's working. So now what we can do is actually log into AWS. And to do that, what you're going to do is type in AWS configure. And once you press enter, it's going to ask you for your AWS access key and your private key. So in order for us to find that, we actually need to head back over to AWS real fast. Once you're on the AWS console, what you need to do is to head over to the IAM services, and you can do that by typing IAM in the search bar right here. Once the page loads, what you'll need to do is head over to this users tab on the left-hand side, click it, then you're going to find your username, click that as well, and then you're going to go over to the securities and credentials tab. Once everything finishes loading, what you'll do is head down to the access key area, and you will need to create a new access key. If you're not super familiar with AWS, it's important to know that you can only create 2 access keys for an account. To create an access key, what you'll need to do is click this button right here, and then it's going to ask you how you intend to use this key. In our case, we're using it for the command line interface, and then it's telling us that we can actually use a few different alternatives. However, we're going to ignore those for now. We're going to accept the risk, and then press next. We're also going to skip this tag description and press create access key. It is important to take note on the best practices that they tell you, such as don't store this in plain text. But in your case, what you'll need to do is copy the access key somewhere secure and copy your secret access key also somewhere secure. Once you've done that, we need to head back over to our command line real fast, and we're going to copy and paste your access key and your private key. And once you enter those, you should be configured to send AWS commands to the cloud using your account. So we're set up, which means we can start running our scripts. So I'm going to start off by zipping up our project by running the npm run zip command. And if you keep an eye over here, you'll see that it creates a new zip project for us. Oops, I was in the wrong file real fast. So I'm going to change to the proper directory and hop back up one directory and go into my Lambda functions and then down to my Twitter follower verifier. Now I should be able to run npm run zip to create this project, and you can see that we have a new zip file down here, which means it's now time for us to hop over to this next step and deploy this zip file to the cloud. I'm going to have to make a small tweak and change this to Twitter Verifier 2 because that's the name that I gave my Lambda function. But just as a reminder, you need to change it to whatever you named your Lambda function. But once you do that, we can hop back down here to our terminal and run npm run deploy, and it will deploy our Lambda function to the cloud. Oops, I made another small mistake. I actually named my function Twitter commit follower verifier 2 instead. So I'm going to save that change. We're going to try to deploy one more time. This will take a few seconds, but once you see a screen like this, you know that it works. And to verify that everything worked, let's head back over to our AWS console, go over to the Lambda function section. Then we'll click on the new function that we just deployed. And once the page finishes loading, what you can do is scroll down here and you can see in the code that we developed locally is now deployed here to the cloud. So this is super cool, and you can actually see our environment variable files if you double click it, your git ignore, and your packages. And yeah, this is awesome. You officially just deployed your first Lambda function and added your own code to it. So congratulations. Now we can move on to the next service in our flow diagram, which is creating a simple queue service. And once we've gone through this iteration once of creating Lambda functions and simple queue services, the rest of this process and video is going to speed by because you're going to know all the fundamentals. So we're just going to work on tweaking each function and queue slightly to make it work for each step of our flow diagram. Speaking of our flow diagram, let's hop back over to that real fast. Okay, we just completed this Lambda function, and now we're about to move on to this simple queue service. The whole purpose of this queue is to pass information along from this Lambda function to the next Lambda function. And as we're creating this simple queue, you'll see that it's actually a very simple process. And after we make it, we'll end up having to do some additional work to tie up this Lambda function to our queue and then have it to where it actually chains it to the next one. But yeah, we're gonna work on that in this next section of the video. So let's go ahead and hop back over to our Amazon console. To access the simple queue service, all you need to do is hop up here to the search bar, type in SQS, and click on the simple queue service. Once the page loads, you should see something just like this. However, yours will probably most likely be empty. In order to create a new queue, what we'll do is hit this button over here that says create queue, and this will bring us up some options above us. And this will bring up the create a queue page. Feel free to name your queue whatever you want to. However, I'm gonna name my queue the tweet commit verified followers to queue. And that's actually the only property that we have to change inside of this queue. It's going to encrypt all of our messages in flight and at rest. And we're just going to keep it with a basic access policy. And then we're going to hit create queue. And now that we've created our queue, what we need to do is hop back over to our Lambda function and update some of the code to get them connected. So I'm going to head back over to Visual Studio Code, go to our index file, and instead of pointing to the simple queue service that I have right here, we need to update it to point to our new queue. You can easily access your simple queue URL by copying this button right here. Come back to our code. I'm going to copy and paste it right here. In my case, it only changed to number 2. In your case, some of the other numbers might update. And since we made a code change, what we need to do is open up our terminal. We need to rezip all of our code. And once it rezips it, we also need to redeploy it. Fantastic. So if we were to head back over to our Amazon Web Service console and traverse over to our Lambda functions and actually visit this Lambda function, what we should find is that the code has been updated once again to point to our new queue. So I'm going to open that real fast, head down here to the bottom, and as you can see, it's pointing to the 2 now instead of what it was originally. And the last step that we have to do to officially connect this Lambda function to our simple queue service is to scroll back up to the top of the page and then press this add destination button. We want to leave the source type as an asynchronous invocation. We also want to go to the condition as on success. And for the destination type, we want to scroll down and do our simple queue. And then lastly, it's going to ask us which queue we'd like to use, and we're going to select the queue that you just created. It might let you know that you do not have the proper permissions to do it, and by clicking save, it'll attempt to add the permissions. That's perfectly fine. So we're going to go ahead and click save, and this might take a second to officially make all the changes. But once it does, your page should look something just like this. Now we can scroll back down to the bottom of our code and update our testing script. In order to do that, what I'll do is click this drop down right here and say configure test event. I'm going to copy and paste some code in here. And what you're looking at is actually an example body of a tweet that we could expect to receive from our server. I've slightly tweaked it and everything, but this is pretty much exactly what you should expect to see when your server makes a post request to our backend. Cool. Now we need to give it a test name. So we're going to call it test tweet. Scroll down to the bottom of the page, press save. Now we can officially press test to run our code. This could take a few seconds. And as you can see, it's giving us a quick error. If I look deeper into this error, what it's saying is that it could not find the package .env. This leads me to believe that we did not properly install all of our dependencies for our Lambda function before we deployed it to the internet. So let's go ahead and hop back over to Visual Studio Code and fix this really quick. Okay, so I'm back over in Visual Studio Code, and as you can see inside this Lambda function, there is not a nodes.module folder, which means yes, we did not actually pass up any of the packages that function needed to run properly. So all we have to do is just run npm I to properly install the packages, and then you know the drill. We're going to do npm run zip to zip everything up. As you can see, it zipped up a lot more this time just because everything inside the node modules folder. And now we can type in npm run deploy. Once again, this will take a few seconds to deploy our code. I'm going to go ahead and actually head back over to our Lambda function. I'm going to refresh the page just so we can see the updated changes. scroll down to the code source, and once this finishes loading, what I would expect to see is a node modules folder. And as you can see, we now do have a nodes module folder, so when I press test again, we can see that our function ran properly and we got a status code of 200. That's awesome. That means everything's working so far. And now what I would expect to see in our simple queue service is a message that is waiting to be processed. So let's go ahead and hop back over to our simple queue service. The easiest way to do that is come back up to our search bar, type in SQS, and then this is going to bring us to a table where we can see all of our different queues. And if you look, this is the queue that we just created, and if you look at the messages that are available, it shows that one message is waiting, and that's the tweet that we just submitted to our queue. So congratulations. We now have our Lambda function hooked up to our simple queue service. And now that you know that how these two services work, we're going to be able to speed mode through the rest of the tutorial. So let's hop back in and create our next Lambda function. So we're officially at the tweet aggregator step. And just to recap, the entire purpose of this Lambda function is to reach out to the Twitter API and pull down as many possible tweets that we can for a specific user. All of the tweets that we pull down are later going to get processed by this tweeted data processor Lambda function and then passed along to our website to generate the heat map. So I just want to provide you guys some more context, but let's hop back over to Visual Studio Code and start building out this function. All right, now that we're back in Visual Studio Code, what we need to do is hop over to the proper folder, which is the tweet aggregator folder. More specifically, we need to go ahead and open up our index.js file. As you can see in this index.js file, we copy a lot of the same structure where we're importing our dependencies up top, setting up Axios to make proper requests, and we're also importing our simple queue service client. In addition to importing our dependencies, you can also see that our handler function follows a pretty similar structure as last time. We're going to do some validation, we're going to make some requests, and we're going to pass this on to the next simple queue service. So let's quickly dive through each one of these functions so you can see exactly how this works. All right, so the first function that we're going to look at is the isValidSQS message. And before we dive into what this function is actually doing, I think it's good to look at what an example SQS message should look like. So whenever our Lambda function sends a message to our queue, and then our other Lambda function is listening for messages to be sent out of that queue, we'll get an object that looks just like this. As you can see, there's an object. Inside that object, there's records. And then inside that records, there's an array of different message objects. In our case, going back to our code, what you'll notice is we're saying, hey, pull out that records by destructuring that object. Then what we do is we check to see if that record array exists. We check to see if that records is an array. We verify that there's only one element inside of that array. And then after that, we check to see if there is a body attribute on the first element in that array. And just to show you what that looks like, as you can see, there's a body, and then this is where our actual tweet will be stored at. So if any of that is false, what'll happen, going back to the top of our function, if any of that is false, we'll return a status code 400 and this function will terminate. However, if that message was valid, what'll happen is we'll continue with our function. In that case, that means we'll head to the getTweet function next. As you can see inside of the getTweet function, all we're doing is basically pulling out the tweet from our record and returning that object in the form of a JSON object. Then going back to our code, the next major function that we're looking at is this get all users tweet for an author. So going down to the code, what you can see is that we take the author's ID as a parameter for our function. And then inside of our function, we are going to do something very similar to what we did earlier when we were trying to get all the followers for a specific user. If you remember in our last Lambda function, what we did is through the use of pagination, we would send API requests to the Twitter API saying, hey, get me all the followers for this user. And we would store the pagination token every time Twitter would send us back one. And we would keep making requests until we no longer received a pagination token. And the reason we stopped then is because if we don't get a pagination token, there was no more tweets or no more followers for us to look at. And that's exactly what we're doing here. We're making a request to the Twitter API to grab all the users, and we are only allowed to grab up to 100 users at one time. If there is a pagination token, great, we'll add it to the end of our query. Once we get a response back from the Twitter API, we're going to do some validation to make sure that there was actually some data in that response and that we received an array of data. If the data was valid, what we do is we concatenate our newly fetched tweets to our existing tweets. We do a little analysis with the response to grab our next token and save it as our pagination token. And we keep going through this while loop until there's no more tweets to grab. And if everything goes successfully, we're just going to return our tweets and head back to the top of our function. Lastly, we're going to count the number of tweets that a user made per day in this function. So let's head down to see how all this works. As you can see with this function, we have a parameter that takes in all the different tweets in an array. And the very first thing that we're going to do is use the map function to go through all of these tweets with the goal of changing the created at property to a string that has the year, month, and day. The reason we want to do that is because later what we want to do is count the number of tweets that a user made on a specific date in the past. Next, what we're going to do is sort all of our tweets based on their creation date. So what this is going to do is, in ascending order, start with the tweets that started way back in the day and then work our way to the current day. Once all of our tweets have been sorted, we're going to head down to this section, which is the number of tweets per day. And basically what we're going to do is turn our dates array into a key object store, where the key is going to be the date and the value is going to be the number of tweets made on that specific day. And if you look through what's actually going on in this for loop, what we're doing is checking in our object to see if we have a date already created in our object. If not, we're going to set it to 0. And then what we're going to do next is add 1 to whatever value was at that previous spot in our object. So just to give you a concrete example, if we were looking at February 4th, 2023, and there was not a key in our dictionary that had that value, what we would do is set it to 0 to start. And then after that, because we do have a tweet on that specific day that triggered this function in the first place, what would happen is we would increment that value from 0 to 1. So we're going to go through that entire object, and that's what's going to get returned back up here to our original function. Then lastly, all this data is going to get packaged into this tweets per day data function and then get passed along to another simple queue service. Cool, so now that you know how that function works at a high level, let's go ahead and get everything deployed, and then we'll come back later once we create a new simple queue service to handle this part right here. So if you remember how we deployed everything last time, what we actually need to do is head back over to AWS and go to our Lambda function section. And the main thing that we're going to need to do is to create a new Lambda function. In my case, I'm going to call it tweet commit, then tweet aggregator. I'm going to name mine 2 just because I've already made this in the past, but you can leave yours how it is right here. We're going to keep scrolling down, and I don't think we need to change anything else. Yep, I think it's good how it is. So we're just going to press the create function down here at the bottom. I think this might take a few seconds to create, but once it's done, what we're going to do is copy this name and then head back over to Visual Studio Code, and we need to open up the package.json for our tweet aggregator folder. This is very similar to what we did in the last one, but what you'll need to do is replace the function name to match our new Lambda function name. I'm going to save it. Then we're going to open up our terminal because we want to start zipping it up and deploying it. I'm going to type in npm run install first so we can add all of our dependencies. Once all our dependencies are installed, I want to do npm run zip to zip everything up in a package for us. And then finally, I'm going to do npm run deploy to deploy our Lambda function and all those dependencies up to the cloud. Cool, so it's all working. Now if we head back over to our Lambda function, scroll down here, you'll see this is the old code. However, if I just refresh the entire page and scroll back down to the code function, it didn't work. Okay, it's because I'm a dummy and I was in the wrong folder. If you actually look down here, I'm in the Twitter follower Verifier folder. So what I need to do is go back up a folder and then go into the tweet aggregator folder. Once I'm in here, I need to run the exact same steps again. So npm I to install everything. Now you can see there's a node folder, npm run zip, and this will make a zip folder for us. And then I'm going to run npm run deploy. This should get everything deployed, but I actually want to check one other thing before we do anything else. So as you can see, we did miss one step. If you look inside at the top of our file, we do expect to have some sort of environment variables. And if you look over here, there are not any environment variables. So what I'm going to do is copy our other one right here, and then I'm going to paste it back over into this folder. Paste. So now we have it, and I'm going to rerun the commands. You're going to know these by heart by the end of this. Npm run zip, npm run deploy. And once this finishes, once we head back over to Amazon with a refresh page, what you'll notice is all of our code is copied over here. We have our environment variables, and then let me double click it, and then we also have all of our dependencies. Now what we need to do is go ahead and deploy our simple queue service so we can officially test out this Lambda function. To create our simple queue service, what we're going to do is click the services button over here, and it should appear as one of our most recently visited ones. So I'm going to open this up in a new tab, head over there, and then I'm going to create a new queue. Inside of this queue, we need to give it a special name. In my case, I'm going to call it tweet commit dash aggregate tweets 2, but you really don't need to. If I was you, I would just call it like that. But now we're going to scroll down to the bottom of the page, leave everything how it is, and then just say create queue. Now that that's made, we're going to head back to our tweet commit function, and then we're going to add a few triggers. On the left side, we're going to add our simple queue service. Type in SQS, click this, and it's going to ask which one you'd like to use. In our case, we want to add our verified followers 2. That was the initial queue that was feeding into this. Scroll down, batch size. We're going to say 1. We only want to do things in ones. And then press add. You might get an error that says you don't have the proper permissions to call this. So what we need to do is actually go inside of our Lambda function and give it explicit permissions to read from this queue. To do that, I'm going to hop back over here, open up another Lambda function tab, click on our Lambda function, and then press the configurations tab. Once this pops up, you'll need to go over to permissions and then click on this role name that you see right here. This will open up a new tab in your IAM console, and what we need to do is add a specific inline policy. So to do that, what you're going to do is click add permissions over here and say create inline policy. Then it's going to ask you to choose a service. In our case, we want to be able to access our simple queue service, so I'm going to type in SQS. Next, it's going to ask us to specify which actions we'd like to allow, and if we hop back over to our initial trigger, what you'll see is that it's asking for us to provide the receive message permission on SQS. So going back to this tab, what we need to do is do the drop down for the read and then click this receive message action. Once we do that, we need to slowly go down here, and then it's going to ask us if we would like to do this for a specific resource or all resources. In our case, we want to only allow this to happen for one specific queue. To find the specific ARN, which stands for Amazon Resource Names, as you can see over here, we'll head back over to our queue list. Right here, we want to go down to the tweet commit verified followers 2, and then you should be able to see all the information that you need specifically from over here. So I'm going to copy this information, head back over to IAM console, and paste this in, and it should auto-populate what you need right here. Press add, and then I'm going to review our policy. This should take a few seconds. We need to give it a name. In our case, I'm going to call it receive message verified followers SQS. That looks good, so now I'm going to press create policy. Great, now our Lambda function has additional policies, so if we head back over to our Lambda function, I think we might just be able to press add one more time. What's funny now is it's asking us to add a new permission. So now that you know the drill, what we'll do is head back over to IAM console, and instead of this time, what we can do, instead of creating an additional policy, we can actually edit this one in line. So what we need to do is click this drop down button over here, add additional permissions, same thing, simple queue service. In this case, we need to be able to write. More specifically, we need to delete a message. Let's just make sure that was right. Yep, delete a message. When it comes to resources, once again, specify one, add ARN. Thankfully, I think I still have mine saved. Press add. We're going to review this policy now that it's working again. Everything still looks good. Save changes. Cool. Now what we'll do is actually head back and try it one more time. It still didn't work, so we're going to go through this process one more time, hopefully. But this time we need to add the get queue attributes. So we'll click this inline policy one more time, add an additional permission for the SQS service. In this case, we want it to be able to not just read, we want to get queue attributes for a specific resource, add it, and then we're going to review our policy, save changes, head back and try it again. Okay, ta-da, it all worked. The reason why we had to end up doing 3 separate policies, going back to our IAM console, let me break you down what each one of these was actually doing behind the scenes. The first one, when it came to receiving messages, we actually just wanted to be able to read things from the queue. The second thing, which was deleting messages, is important because once we properly handle a message from the queue, we want to delete it out of the queue so it doesn't get reprocessed by something else. And the last one, when it comes to get queue attributes, we just want to see how many items are in the queue and a few other properties. But cool, so now that you're an expert on adding inline policies for Lambda functions, we need to hook up a second simple queue service over here in the add destinations. And it's gonna be just like what we did on the previous Lambda function. So it needs to be an asynchronous invocation, it needs to be an on success, it needs to be an SQS queue, and then what we need to do is we want it to head to the tweet commit aggregator queue. We're going to press save. As you can see, it's going to try and add another permission to make everything work. And fantastic, it's all been set up. And to fully get this Lambda function working, we have two final steps. The first is we need to update our code to point to our new simple queue service. And the second thing is we actually need to test it out using our test button down here. So first, let's update our code to point to the proper simple queue service. We can do that by headed down here. And then we need to copy this URL. Now we'll head back over to our Visual Studio Code, go to our index, and like I said, this is pointing to my old URL. So we're gonna paste it here, save it, and then you know the drill. We're gonna do npm run zip, and then npm run deploy. And then once this deploys, if we head back over to our code for our Lambda function and refresh the page, and then head back down to our index.mjs file, what we should see now instead is it should say 2 instead of nothing. Fantastic, cool. So the last step that we have to do is to test out this function. So all you need to do is head over here and grab this test.json file. We're going to copy the contents of it, click this drop down and configure our test event. We're going to copy and paste our new JSON object in there, and then just call it our aggregated tweets test. Go to the very bottom, save it, and then now we can test out our function to see if it's actually working or not. So let's press test. And after doing a little bit of debugging, what it looks like is that there's an error on line 80. So let's hop back over to line 80 real fast. And it apparently does not like our parsing. So I'm just going to erase that and make this change, deploy it. And now what can happen, once it finishes deploying, we will retest our code by pressing test, and then hopefully everything works. Okay, great, we get a status code of 200, which means everything works. So let's go ahead and hop back over to our flowchart and just see where we're at. So let's head back over to Excalidraw to see where we're at in the flow diagram. All right, so we're chugging right along, and we're actually getting to the parts where we can start going really fast through the rest of this process flow diagram. So what we're about to do next is create our next Lambda function that is connected to the queue that we just created. And this Lambda function is going to talk to a DynamoDB. So that's where we're headed. So let's go a bit. So let's dive back into AWS and create our next Lambda function. And this Lambda function is going to talk to a DynamoDB. So that's where we're headed. So let's dive back into AWS and create our next Lambda function. And now that you're becoming pros at AWS, you know that we need to go over to our console. We need to click on Lambda. And from there, whenever it loads, we need to create another function. You could probably be doing this in your sleep by now with how familiar you are with all of this, but we need to generate a new function name. So I'm going to call it tweet commit dash data processing. Scroll all the way to the end to create a new function. And now that it's finished creating the Lambda function, let's head back over to Visual Studio Code and go to our data processing folder so we can inspect what's actually happening inside of this Lambda function. And I'm gonna go ahead and do what we normally have to do, which is change directories over to our tweet data processing folder. And then we're gonna do our normal npm install to go ahead and add all of our dependencies. And like we do every time, I'm gonna go ahead and walk you through what's happening inside of this file. At the top of our file, we're importing our normal dependencies, except one of the big changes that you'll notice is instead of importing simple queue service, we're now importing DynamoDB. And the reason that we're doing this is because after we do some of our data processing, we need to save the data that we generate to a NoSQL database. The reason we want to do that, going back to our original flow diagram, is we need a way for our websites to access data. And since we can't go from a Lambda function to a website, we have to go from a Lambda function to a database, and then from a database to our website. So I know it's a little confusing, but it'll all make sense here in a second. But that's the main reason why we're importing this library. Okay, so let's keep going down the list and looking at the different functions. Once again, we're doing some validation to make sure that our simple queue service message is a valid message. You've seen that a dozen times now, so we're going to skip that. The next thing that we're going to do is go to our get aggregated tweet data. This is the same function that you saw last time, but what I'm going to go ahead and do is get rid of that JSON parse issue since that caused some issues last time. Go back up, and you'll notice that the next function that we have is get tweet milestone data. So this function is a little confusing because I set out to do something differently initially. What I was trying to do when I first made this function was allow you to create graphs for 30 days, 60 days, 90 days, and a whole year. However, I made it to where you actually just can create it for a single 1 year look back. That's why you say 365 days here, but I initially had a commented out array that had a lot more milestones in it. So we're going to be able to go ahead and delete that comment. Now let's go ahead and look at what's happening in the rest of the function. So most of the magic starts here on line 69, where we create a new day.js object. And if you're unfamiliar with this library, basically what it does is it allows you to do date manipulation very easily. And in our case, what we're going to do with this day is, if you look at this for loop, is we're going to start at the current day and we're going to iterate through our for loop, and on each iteration we're going to subtract a day. And every time we subtract a day, what we're going to do is look back in our aggregated tweets dictionary and see if any tweets were made on that day. If no tweets were made, we're going to mark it with a 0, but if tweets were made on that day, we're going to store that value. So that's what you can see what's happening here. We're basically going to say for this key, update it to these values. Next, what we're going to do is update our maximum tweets. I don't know if you're familiar with the GitHub chart that we're trying to create, but what you'll notice is on very active days of making commits, it's a light green color, and on non-busy days, it's dark green. So this maximum tweets variable that we're updating is going to help us gauge that upper threshold of tweets made for a specific user during the year. Lastly, this milestone section is kind of confusing because it was made for having multiple milestones, such as the 30 days, 60 days, 90 days. But what it basically is going to do is at the very last iteration through this for loop, it's going to create a new milestone and push it to our milestone data array. And then that's going to get returned. So this is set up for you to actually generate a lot more graphs than we're making right now, but it's a little overcomplicated. So feel free to refactor it. Okay, cool. Let's head back up so we can look at the next function. In our case, the next function is this batch write tweet milestone data. So let me walk you through what's happening real fast. The first thing is this tweet milestone data parameter. As we just got done discussing in the last function, we're going to have an array of milestones. Unfortunately, there's only one milestone for right now, but just know that's what's happening. Next, we're going to start setting up our DynamoDB client. This might not make total sense yet since we haven't set up our DynamoDB table, but we're going to do that in the very next section. But just know this is going to be the name of the table, this is going to be the region, and then what we're going to do is a batch write. I personally thought this was a confusing way to write data to a database, but let me just walk you through what's happening real fast. What we're going to try and do is write our tweet milestone data to this DynamoDB table, and what we're going to do is map each one of our milestones to a put request. And then what we have to do is break it down per item. And this Marshall function, what it does is it makes it to where everything is type safe. So if we're passing an object that has a name, that's a string, a max tweets, which is a number, this marshalling function properly formats our data to where it's type safe before we send it up to our DynamoDB table. So once we've set up these parameters, we're going to send off a batch write command and pass in these parameters. Then what we're going to do next is tell our DynamoDB client that we want to send that command. So we're actually returning a promise. So if we go back up to the very top, what you'll see is that we're going to await this promise and get a result. If everything goes great, what we're going to do is return a status code of 200 to let the user know everything went great, and we're also going to return the milestone data that we saved. And if something went wrong, we're going to return a 500 error. Okay, cool. So let's go ahead and do what we normally do and start deploying this to AWS. So I'm going to go ahead and do npm run zip. And now I'm going to head back over to our package.json file to make sure that I'm using the proper Lambda function name. And in this case, I'm not, so I'm going to delete it real fast and change it to the proper name, which is tweet commit data processing. Save the file. And now whenever I go down to our terminal, I can run npm run deploy. And once this is finished deploying successfully, I can head back over to our Lambda function, refresh the page. And whenever I scroll back down, I should see that our code has been updated. Great, fantastic. It looks like it's all working now. So what we can do is move on to the next step, which is actually creating a DynamoDB table. In order to do that, what we're going to do is head back up here to the search bar, type in DynamoDB, open this in a new tab, and head over there. Once this page loads, what we're going to do is click create a new table. And now I'm going to walk you through exactly what you need to do in order to create your first DynamoDB table. In our case, we're going to want to name this table. I'm just going to call it tweet commit milestones 2, since I already have one of these. We're going to set the partition key to be ID, and then we're going to leave the sort key blank. And just to recap, in case you're not familiar with these terms, the partition key is basically the primary key that you want to be able to use to look up each one of your items in your table. So it's just the unique ID. And the sort key is basically a secondary key that you can use to search amongst your data. So that's pretty much just everything at a high level, but we're only sticking to the partition key. Scrolling down for the rest of the page, we're pretty much just going to leave everything how it is for simplicity's sakes. And just as a heads up, everything is under that free tier, so you really don't need to worry about everything. So we're going to head down to the bottom and press create table to create our first DynamoDB table. And just to give you a heads up, it usually does take a few seconds to create your table. But now that it finished successfully creating our DynamoDB table, we have one additional step, which is going to be going back over to our Visual Studio Code and then checking to make sure that we're pointing to the right DynamoDB table. So if you look at your index.mjs file inside of your tweet data processing folder, you'll see that we need to point to the right DynamoDB table. In my case, I need to change it and save it to a 2. And the reason why I need to do that is because that's the name of the DynamoDB table I just created. So you'll need to make sure that matches yours. But now we need to do the normal drill of zipping everything up and deploying it. So let's just make sure we're in the right folder first. And we're not, so I'm going to cd over to our Lambda functions folder and then our tweet data processing folder. And then I'm going to run our npm run zip and then our npm run deploy just to make sure everything's working properly. And I would expect once this gets deployed, if I head back over to our code, perfect. I'm going to head back over to our code, go to our Lambda function. I'm going to refresh the page. If I scroll down to the bottom, what I would expect is it should point to a 2 now. Fantastic. So it's working. In order for us to officially be done with this file, we have 2 last steps. First, we need to head back up to our function overview and add a trigger. In our case, we want to point back to a simple queue service. So once again, I'm going to type in SQS. And then this time, I want to point to our tweet commit aggregated tweets 2. I want our batch size to be 1, the batch window to be 0. That's fine. And if I scroll all the way down, everything else looks good. So I'm going to press add. And we're going to run back into that same issue that we ran in last time where we need to add 3 separate inline policies. So what I'm going to do is duplicate this tab, go back into our Lambda function. Let me find it real fast. It's over here on our functions tab. I go to last modified. It's the one that was done right here. If I go to our configuration, go to our permissions, and I click this role name, it'll bring us back over to our IAM permissions. And similar to last time, we need to just click this add permission over here and say create inline policy. It's going to ask us which service we would like to use, and we're going to say that we want to enable this to talk to the SQS service. And then it's going to ask what actions do we want allowed to use. So if you remember from last time, it was the get queue attributes and then receive messages. In addition to that, it was the delete message. And now that we selected those, we can just go ahead and scroll down to this resource section right here. And just like last time, we only want to allow this to apply to a specific SQS resource. So I'm going to hop back over here. I'm going to go to SQS to look up our different simple queues. And then I'm going to click the right queue, which in our case was this tweet commit aggregated tweets 2. So if I click that, I'm going to be able to copy the ARN, hop back over to our IAM management console, paste it in right here. Everything should be auto-filled, press add. We're going to review our policy, and now we're going to give it a name just like we did last time. So I'm going to call it aggregated tweets data processing Lambda SQS. Something just like that, so we know exactly what's going on. I want to create policy. And then now if we hop back over to our Lambda function, press add again, what should happen is it should hopefully work. I'm going to add it one more time. Sometimes it might not instantly add the inline policy, so you might have to try it a few times. But great, now that that's done, the only thing left that we have to do is go back over to code. So we want to make sure that everything's working, so we're going to hit this button right here, and we're going to update and configure our test event. And I've already generated all this dummy data for you, so all you need to do is head back over to Visual Studio Code, go to the test.json file within the tweet data processing. We're going to copy it all, come back over here to our configure test event, and I'm going to paste the code here. And if I scroll all the way to the bottom, it's going to ask me to save, but we need to give it a name first, so I'm just going to go up test data processing. Head back down to the bottom, I'm going to save it. And then now what we should be able to do is if we run test, it should hopefully properly execute our code, but it didn't. And if you notice why, it's saying that access denied. More specifically, the DynamoDB batch write item on this resource is not allowed. So what we need to do is add one more permission to this Lambda function. So what we're going to do is go back over to our configuration, hop back down to permissions, click on our role, and we're going to add another inline policy. So you guys know the drill by now. We're going to hit add permission, create inline policy. In this case, we just want to do DynamoDB. What we want to do next is go inside of the right toggle down here and click batch write item. Then we're going to scroll down because we want to specify which resources we can use for this. So I'm going to click add ARN. And then if we go over to our DynamoDB table, we should be able to click it and copy the ARN for the specific DynamoDB table. To find out what you're going to want to do is click this additional information and then copy this Amazon resource name. Head back over to your IAM policies, paste it in here, and then press add to add it. And then if we scroll down to the bottom, we're going to go ahead and review our policy. We're going to name this data processing Lambda DynamoDB. And then we're going to say create policy. And now if we head back over to our Lambda function, we should be able to try it out one more time to see if we're going to hit any more issues. So let's do test to run it one more time. And as you can see, we got a status code 200. But what's even more cool is if you head back over to your DynamoDB table, let's go into our explore items, you can see that we actually wrote a record to our table. So congrats, we're now not only just managing our backend, but we have a database that we're writing data to. So you are officially a backend champ. Now that this is working though, we have a little bit more work to do on our Lambda function. And now that this is working, let's head back over to Excalidraw so we can see where we're at in the overall flow and what steps we need to work on next. Okay, so let's recap what we've just done. We just made our DynamoDB table and we're sending data to it from our tweet data processing Lambda function. So what we need to do next is set up our DynamoDB stream. And if you're not familiar with these streams, basically what they do is they send a notification anytime something happens to the database. In our case, we're going to send an event to be triggered if a new item is added to our DynamoDB table. This event is going to be sent to our next screenshot request Lambda function. And we're going to dive into that one next because it's a little complicated. But yeah, just to recap, we're going to build a DynamoDB stream and then start working on this Lambda function. So let's go ahead and dive back into our AWS console. Okay, so we just hopped back over to the DynamoDB page. So to set up our stream, what we're going to want to do is click on the tables button over here, find the table that we'd like to update. And once we're here, we're going to go to this exports and streams tab. So let's click that. And at the very bottom of the page, there's a section that asks if we'd like to set up our DB stream. In our case, we're going to go ahead and turn this on. And then what you'll see over here is that it asks which version would you like to set up the stream. We can set it for specific attributes, new images, old images, or basically any changes. Since we only care about new changes to our database, I'm just going to click new image and turn on the stream. And now that we've set up the stream, what we need to do is if you scroll down to the bottom, it says, do you want to create a trigger? Basically, this trigger is going to be invoked anytime our stream notices something that has happened. So in our case, let's go ahead and hop back over to our Lambda functions by going up here, typing in Lambda, and creating the next Lambda function. And to do that, I'm going to go ahead and click create function. And I'm going to call this one tweet commit screenshot request. Scroll down to the bottom and press create function. And now that this function is getting set up, I'm going to head back over to our DynamoDB table. And then I'm going to update this create trigger button and search for our tweet commit screenshot request Lambda function. Batch size 1 is fine. And then I'll press create trigger. And per usual, we're going to have to set up new IAM functions for the new Lambda function that we just created. But thankfully this time it provided us a list of actions that we need to add to our DynamoDB stream. So let's go back to our Lambda function, click configurations, go to our permissions, our role name per usual, hit this add permissions button. We're going to create an inline policy. We need to work with our DynamoDB, and then let's just go one by one. I'm going to go ahead and open it back up real fast too so we can see exactly what's happening. So the first thing we need to do is add the get records and the get shard iterator. So get records and get shard iterator. Fantastic. Next, describe stream and list streams. There's list streams, and then there is describe streams right here. And cool, those are all the actions that we needed to add. So let's go down here to specifying our resource, and then I'm gonna add an ARN. In order to do that, I'm gonna head back over to our DynamoDB table and click this latest stream ARN right here. Now that's copied, head back, paste it, everything should populate, press add, and then we're pretty much good to go. We're just gonna review our policy, and then once it's done, we're going to create it. Oh, sorry, we gotta give it a name real fast. So DynamoDB stream milestone, screenshot request. Fantastic, create policy. And now while that's making, let's go ahead and head back and finish setting up our trigger. So we should be able to look for this new Lambda function, screenshot request. Now when we create it, it should work. Okay, cool, fantastic. The trigger has been successfully set up. So if we come down here at the bottom, everything's working fantastic. Now that we have our Lambda function set up to listen to new objects created into our DynamoDB table, thanks to that DynamoDB stream, we're gonna hop back over to our Lambda function and start coding it up. But before we do that, I wanna show you in Excalidraw exactly why we're having to do this kind of funky hop around data from our Lambda functions to an API gateway to another Lambda function. It all makes sense in 2 seconds. So let's go ahead and hop back over to Excalidraw. Okay, so let me quickly explain what's happening with these 3 services right here to make all this make sense. At a very high level, what we're trying to do is take a screenshot of a website that we're going to create here in just a little bit. The website that I'm talking about is actually right here. In order for us to take a screenshot of that website, the way it works is it's at a specific URL, and what it's expecting is some sort of milestone ID. This milestone ID actually comes from our DynamoDB table. So what we need to do is pass this milestone ID all the way around through these different Lambda functions into our website and come back. So it's kind of a weird loop, but let's walk through what actually happens. This Lambda function right here is listening to our DynamoDB stream, and its actually whole goal is to pull out our milestone ID. Once it pulls out this milestone ID, it sends it to this API gateway, which instantly passes it over to our another Lambda function right here. This Lambda function is actually written in Python and Selenium. Let me write this out real fast. Python and Selenium. And what it does is it uses, and what this Lambda function does is it loads and at a very basic level, what this Lambda function does is it loads the website and then just takes a screenshot of the heat map that's generated on it. Once this Lambda function does take a screenshot, it passes it to an S3 bucket so we can handle processing it and DMing it to our end Twitter user. But just to recap, our DynamoDB table, we have a DynamoDB stream which alerts us when new records are written to our table. We have a Lambda function hooked up to this stream, and its whole purpose is to pull out the milestone ID. The second it has its milestone ID, it passes it to an API gateway which is hooked up to a Lambda function. So we're going milestone ID, and it's just looping all the way around over here to this Lambda function. The second this Lambda function grabs something, it's going to, with Python and Selenium, make a request to load this website, and this website has the Twitter heat map. It's then going to take a screenshot of it and pass it to an S3 bucket. So that's kind of how this whole flow goes. So let's start working function by function. So let's start working service by service to get this all hooked up, and I think it'll make a lot more sense. Plus, once you actually see the website, this will all click. So let's hop back over to the code and knock all this out. Once it pulls out this milestone ID, it sends it to this API gateway, which instantly passes it over to our another Lambda function right here. This Lambda function is actually written in Python and Selenium. Let me write this out real fast. Python and Selenium. And at a very basic level, what this Lambda function does is it loads the website and then just takes a screenshot of the heat map that's generated on it. Once this Lambda function does take a screenshot, it passes it to an S3 bucket so we can handle processing it and DMing it to our end Twitter user. But just to recap, we have a DynamoDB stream which alerts us when new records are written to our table. we have a Lambda function hooked up to this stream, and its whole purpose is to pull out the milestone ID. The second it has its milestone ID, it passes it to an API gateway, which is hooked up to a Lambda function. So we're going milestone ID, and it's just looping all the way around over here to this Lambda function. The second this Lambda function grabs something, it's going to, with Python and Selenium, make a request to load this website, and this website has the Twitter heat map. It's then going to take a screenshot of it and pass it to an S3 bucket. So that's kind of how this whole flow goes. And I actually think the easiest way to do this part is to build backwards. So what we're going to do is first start off by building our website, and then start working on our Lambda functions, gateways, and our other Lambda functions. I think this way is going to make the most sense, and it's going to be cool to visualize the website that we're building and going to take a screenshot of. So let's go ahead and hop back over to our code and start building this website. Okay, so here's the website that we're building, and as you can see, it's pretty straightforward. It's just an empty screen except for our tweet heat map at the top. This tweet heat map is at a specific height and width to make for a nice picture. And this website was actually built using the T3 stack. This is my go-to stack whenever I want to create any web application nowadays. But the nice part is I didn't have to do a lot of the extra work for adding a backend or anything like that. It's pretty simple. We're just going to make one request to our backend database, pull down data, and then display it. But we are going to be using Tailwind to generate a lot of the graphics that you see here. So let's hop over to our Visual Studio Code instance and actually start looking through the data so you can understand what's going on. So this is probably about to be the most basic T3 stack app that you've ever seen, but I just want to walk you through it really quickly. So the main thing that you need to know is that this is a React app. So the entry point that you're going to see where all of our initial components are stored is inside this tweet graph container component. This is pretty much the only component that's actually doing anything inside this entire function. It's kind of long, but I'm going to walk you through it real fast. And before we do that, what we need to do is go down to our terminal, and we're actually going to hop over and install everything inside of our tweet commit graph using the npm I function just to get rid of these red squigglies. Now that that's cleared up, what I'm going to do is actually start going from the top to the bottom so you can understand how all this code is working. And I'm also going to hop back to the website real fast just to walk you through a few important things that are happening. So as you can see, we have some sort of website that this is hosted on, and we're making a query based on a certain milestone ID that links to the ID of the data that was stored in our DynamoDB table. What our website's going to do is with this ID, it's going to make a fetch request to our backend database and pull down this DynamoDB object. This object stores the amount of tweets that were made per day, the author of this tweet, the start and end dates of the tweets, and the maximum number of tweets created. The maximum number of tweets created is going to help us shade these tiles very light if there's a lot of activity, or dark if there wasn't that much activity. And that's pretty much a recap of how this entire function works. We're going to use this milestone ID to pull down data from our DynamoDB table, and that DynamoDB object is going to have all the data that we need to generate this graph. So let's hop back over to the code and link all these different processes and tasks up so it makes sense. Okay, so let's speed through this component pretty quickly. As we mentioned earlier when I was pointing out the website, the main starting point was to pull out that milestone ID from our URL bar. Let's skip past all this and hop down to the first use effect. What we want to do with this use effect is anytime the milestone ID changes, we want to make a fetch request to our backend database, which we're going to set up in just a second. And what we want to do is make a post request with this milestone ID. We're then going to get back some data, and then we're going to format that data. And because this is TypeScript, we need to say what kind of data we're going to get back. In our case, it's going to be tweet milestone data with our author ID, end date, max tweets, and just overall general tweets. I'm then going to do some just very super basic validation. We really should be using Zod or something else to ensure that we're getting back the data we expect. And for some reason, whenever we get the object back from DynamoDB, it sets our tweets as a string. However, we don't want our tweets to behave as a string. We actually want them to behave as an object where the key is a date and then the value is a number, as you can see right here. So we had to do some fancy stuff right here, but it'll work. And this leads us to the next part of our function where we're actually setting the data. In our case, this is the tweet milestone data. So if we go down to the next use effect, you can see that it is triggered every time the data object changes. And let's walk through what's actually happening real fast. So what we're first doing is checking to see if there actually was data. If there's not data, we're just going to blank out our chart and set everything to 0. However, if there is actual information inside this data, what we're going to do is call the getSortedTweetsValues function, which is up here. And this function actually does something pretty critical. So let's hop back over to our website real fast. So back on our website, here's pretty much how it works. if you count, we have 1, 2, 3, 4, 5, 6, 7 tiles going down. So each column that you're looking at represents a week. And then if you're gonna count how many columns there are in total, there's actually 52. So 52 times 7 is actually what? 364. So that means that there's actually, in our case, when we say there's 365 days in a year, that is true, but for our graph, we only are gonna display 364 tiles. And the way we're gonna do it is we're going to pull out all the key values from our tweets objects. And remember, our keys are actual dates. We're going to sort those dates, starting from the earliest, which in this case would be a year ago, so it's gonna be early March. And then we're going to iterate through these dates in a custom way to where we start in this tile, go down all the way, start over here, and basically fill it up this way. Because if we were just to iterate through our normal array this way, if we were to do March 1st, March 2nd, March 3rd, March 4th, it would actually mess up our graph. So long story short, we need to iterate through our data in a custom way. So let's hop back to the code so we can see all this happening. So as I mentioned earlier, what we want to do is sort our data going from ascending order, where the first objects in this keys array are the oldest one. Then what we want to do is make sure that everything will fit in our nice 7 by n graph. So in our case, 7 by 52. What we're going to do next is actually iterate through each one of our keys and pull out the corresponding values. So we're going to end up with 2 arrays, a key array and a value array. And then at the very end, we're just going to return that value array, which you can see we're using right here. And then finally, what we're going to be doing is using our useState functions from React. We're going to set our max tweets. We're going to set all the values that we just pulled out that are thankfully sorted from the oldest date to the newest date. And then finally, we're going to set the months that get displayed on our graph, which in our case are going to go from March to February. This function was a little bit tricky. I actually have it set over here, but what it basically does is it compares the start date to the end date, sees how many months are in between them, and then we just keep subtracting back, and we put together an actual list that starts with, let me just show you real fast, that would actually go from February, January, December backwards. So yeah, so that's how that function works. Cool, so now that you have a pretty good overview of how this function works, what I want to show you next is how these tiles get generated, and then that's pretty much all you need to know about this website. Okay, so for the magic for generating the tiles, what we're basically doing is we're going to iterate through each value of how many tweets were made per day. So in our case, we're going to iterate from 0 to like 365. But as I mentioned earlier, we can't just go 0, 1, 2, 3, 4. We have to actually do some magic converting this 1D array into our 7N array. So this is what this convert index to week index function does. And I'm gonna let you look at the math real fast. Feel free to shoot me a message if this doesn't make sense, or heck, ChatGPT would be good to help too. But let's go back to our component real fast. What we're gonna do next is, because we know the week index, what we're going to do is pull up how many tweets were made. That we're gonna pull up how many tweets were made on that specific day. And then we have another function that basically says, okay, well, were there a lot of tweets on this date comparative to the max tweets? And then we're going to shade the color of that tile based on what we see. And what I found that it gets actually too dark below anything below 15% transparency. So that's why I have a minimum of, hey, if there was any tweets made on a day, just go ahead and throw a dark green on it. Because if not, you can barely tell a difference. So then going to the very bottom, back to our components real fast, I kind of just want to walk you through what you're actually seeing here down in the HTML code. We're using Tailwind to do everything. So what you're seeing is, hey, I want to generate a 275 pixel by 1600 pixel container. I want to display everything in a row, and I want the background to be black. So all that makes sense. Long width, short height, black background. And then what we're doing inside of that is we're actually going to do 3 major things. The first one is what we want to do is list out all the months. So that's our first row of white text. It's basically just iterating through our months list that we created earlier and showing it up on the top. The next row that it's going to show is our generated tweet tiles. So hop back up here real fast. And this is kind of what I was showing you earlier, to where we're just going to generate a tile that's going to have a green, black, based on the number of tweets made per day. So that's this entire middle part. And then the very last bottom part is basically our footer, where I'm going to say, hey, to see all your tweets, do this. Basically, this is how I was giving instructions to them. However, for your channel, what you'll probably want to do is tell them to follow your account instead of my account, and then give them specific instructions on what they need to tweet in order for all this to get triggered. What you're looking at right here was actually the rule we created at the very beginning of the video. So it's coming full circle, and it's only taken an hour and a half to get there. But what you're looking at right here was actually the rule we created at the very beginning of the video. So it's coming full circle, and it's only taken an hour and a half to get there. But dang it, it's gonna happen. Okay, so that's pretty much how all this works. So let's focus on actually getting this deployed to Vercel so you can start running your own website. So there are two keys to getting everything deployed to Vercel. First, we have to push everything to GitHub, and then we have to set up a Vercel account to point to our GitHub. So let's go ahead and do that real fast. So I'm over here in GitHub, and I already have a repository set up with all of my different functions in it. If you've never done this before, there's plenty of resources out there, but basically what you want to do is create a new repo, and then you'll come back over to your code over here in your tweet commit graph. You'll initialize a new Git repository, and then push all your changes up to your own repo. Cool, now that you know how to do that, let's hop back over to Vercel. Basically with Vercel, what you'll want to do first off is create your own account, which is completely free. And then after you do that, what you'll do is click Add New and then Project. Once you press Create a New Project, it's going to ask which repository would you like to use on your GitHub account. And at first, you might have to allow it to connect to your GitHub account, so there might be a button here to say Connect to GitHub. But once you do it, what you'll do is come down and find the repository that works. So this was the repository that I had set up. And you just click import, and then what you'll do is come down and browse for the repository. So in my case, it was the tweet commit graph repository that had my Next.js application. So I'll press continue, and then you go all the way down except for this one stage right here where you need to add environment variables. And there's one specific environment variable that you need to add to your repository. And to find this variable, what we need to do is head back over to our Amazon console, and we need to go to our API Gateway. The variable name that we're looking for is actually the URL of our API Gateway. So if we go down to stages, click development, and it's actually this URL right here. So let's copy that, go back over to our editor. We're gonna paste that over here in our value. And for the key, we're gonna call it AWS base URL. Fantastic. Then you're going to press add, and then next we're going to press deploy. And this should take a few seconds to work, but what's going to be cool is because the way that Vercel actually detects changes, if you make any commits to your master branch in GitHub, it'll detect that a change was made, and it will actually trigger a new deployment of your website. So you pretty much always have an up-to-date version of your project thanks to Vercel. So that's super cool. So we're going to give it a few seconds to actually build and push all our code out. Once it finishes deploying, you basically should get something that looks just like this, to where you can click visit, and it'll actually take you to your website. So this is pretty awesome in my opinion. Obviously, we're not pulling any data because it's not doing any of the milestone stuff. But yeah, this is pretty much working. So now we have a working website. So what we're going to do next is hop back over to Amazon Web Services and create another Lambda function that's going to actually take a screenshot of this website. To create this new Lambda function, let's actually head back over to our AWS console and click on Lambda. Once the page loads, we're going to click Create New Function. And then this time, instead of using our Node 18 environment, we're actually going to use Python 3.7. The reason we're changing things up this time is because I'm actually following a tutorial made by this guy. I don't want to butcher his name, but here's his name, and I'll put a link to his channel in this video down in the description below. But if we actually go ahead and look at his GitHub, you can see that we're pretty much using this code.py, and we're also going to be using this .zip file. So let's head back over here, and we're going to call this tweet commit screenshot. Scroll down to the bottom, and yep, I don't think we need to change anything, so let's press create function. Okay, cool. Now that the function's been created, we need to head back over to Visual Studio Code so we can deploy the proper code to this Lambda function. Okay, so let's go ahead and open up our Visual Studio Code, and all of the code that we're looking for this Lambda function can be found under the tweet commit screenshot folder. So let's go ahead and open up our code.py and our deploy.sh file. So I'm gonna split the screens real fast so we can look at everything at once. And let me do a quick walkthrough of what's actually happening with this code. So up here at the top of this code.py file, what we're basically doing is importing everything. And as I discussed earlier, we're using Selenium, which is basically a library that allows us to do things on the web. More specifically, in our case, take a screenshot of a Chrome browser. So I'm gonna scroll down here a little bit more. In this next section, we're actually gonna set up some of our keys and environment variables. I just went ahead and hard coded these access keys because I'm just doing this for testing purposes. So these access keys won't be saved here when you're actually using it. So feel free to deploy it, but don't save it to your GitHub just because you don't want the world to see your access keys. I'm gonna keep scrolling down and you can pretty much ignore most of this. This is just setting up all of our web drivers and everything. The main things that we're gonna be aware of are saving our screenshot, and the way that all of this gets called is down here in this Lambda handler function. So let's walk through this part pretty quickly. What's going to happen is this Lambda function is going to get a request, and very similar to what we've done earlier, it's going to validate that this request was valid. If it is, it's going to keep going through. And at this point, what's going to happen is we are going to extract the URL and the author ID from the initial event that gets passed to this function. We're then going to trigger Selenium to go take a screenshot of this specific URL and to save the file to this path. Basically our local temp directory, and we're going to save it as the we're going to save the name of the file as whatever our destination path is. We're then going to set up our Amazon S3 client with our access keys and private keys and region name so that we can then upload our file to our S3 bucket. So I'm going to go ahead and deploy this function to the cloud, and then we're going to add a layer to our Amazon Lambda function. And then after that, we're going to set up our S3 bucket. And again, all this code's in the GitHub, so you feel free to look at it and study it more. The only action that you'll need to change in this file is updating your access keys right here. Okay, cool. So let's focus on deploying it now to Amazon Lambda. And the main thing that you need to worry about in this file is updating the function name to match the function name that you just created in Lambda. So let's hop back over there real fast, and you can see that we called it tweet commit screenshot. So I'm going to copy it real fast, come back here and paste it. I'm going to save it. And then now if we open up our terminal, let's make sure we're in the right directory. So if I do pwd, you can see that we're inside the tweet commit screenshot directory. Great. So all we need to do next is to make sure that we can deploy our function to run our deploy script. So next we need to run our deploy script that you're looking at right here. And if this is the first time you're doing this, you need to probably change the file to where it can be executed. So we just change mod plus X to this script. And then now what I can do is I can run deploy.sh, and this should zip up our package and then deploy it over to our Lambda function. Great, so it looks like I did everything properly. So let's head back over to our AWS console and make sure everything worked properly. Okay, cool. So back over in our AWS console, I'm going to click the function that we're creating. And if I scroll down, I'll actually see our code deploy function. Fantastic. So what we need to do next is actually add a layer. Whenever you click the add layer button, it'll bring you down to the bottom of the page, and you just click this add a layer button. So when you get to this screen for the very first time, what it's going to do is say, where is your layer at? So what you'll have to do is actually upload the .zip file. Let me show you which one. This Chrome headless.zip file. You'll have to upload it to Amazon and then point to it. Usually what you'll do is upload it to the S3 bucket that we're going to work with, and then you'll click specify in ARN and actually go and copy and paste that Amazon resource name and paste it in here. But once you do it, you'll be able to come back here and choose the layer that you want to use. So in our case, it's the Selenium Python.3, 1, press add. And if you get stuck on this step, don't worry, feel free to shoot me a message on Twitter and I'll be happy to help you out. I'd also like to point out that the video that I'm basing everything on had a fantastic walkthrough of adding layers to Amazon. So feel free to use that as well. Great, once that's set up, what'll happen is you'll see that our layer now has a 1 to show you that we are linking it. And the reason why you do want to add layers is because we're using all these different libraries and they get pretty large. So layers are a way to extract those libraries and keep them somewhere separately. So what we need to do next is add an API gateway that's linked up to this specific Lambda function. So in order to do that, I'm going to come over here, hit services. I'm going to go to our API gateway. Once I click this, I'm going to open it up in a new tab. And we need to build upon the previous API gateway that we created earlier. So I'm going to click tweet commit to. In your case, it might just be the existing one that's already there. And we're going to repeat the same process that we learned earlier, but instead of adding tweets and making a post command, this time what we're going to do is create a new resource that's going to be for our milestone. Fantastic. I'm also going to say enable gateway cores on this one. That's going to be important. Once you press create, you should see something that looks just like this. And then now I'm going to click our milestone and I'm going to add a method on it. In our case, I'm going to make a post method, press check, and then I'm going to link it up to a Lambda function. In our case, it's going to be our screenshot one, tweet commit screenshot, and then I'm going to press save. It'll do its best to go ahead and add a permission to that Lambda function. So let's see if it's able to create everything properly. And it looked like it did. So let's head back over to our Lambda function and refresh the page, and they should have a new trigger over here that's hooked together. Fantastic. So let's hop back over to our Excalidraw so we can see what we need to do next. Okay, so let's recap what we've just done. We made our new Lambda function that takes a screenshot of our website, and as y'all saw earlier, we built our website and deployed it to Vercel. We also just added a new API Gateway Endpoint to our milestones. So what we're going to need to do next is create another endpoint on this API Gateway for screenshots, and then we're going to have to come back here and repopulate our screenshot request Lambda function. Once we've done that, which are creating our S3 bucket to store all the images that we're making, and then our very final step is to create our final Lambda function, which is actually going to send a DM of our screenshot to the person who sends us a message on Twitter. Okay, so let's hop back over to AWS console to get everything working. Okay, so let's hop back over to our Amazon Web Console real fast so we can finish creating this Lambda function that receives items from our DynamoDB stream. And if you remember, this one was actually called the tweet commit screenshot request Lambda function. So I'm gonna click it right here. And as you can see, we left this empty on purpose beforehand because we needed to do some more work downstream. But let's go ahead and head back over to Visual Studio Code so we can deploy all the code in here real fast. All right, so here we are inside of our index.mjs file. And just to recap, you need to be inside the tweet commit DynamoDB folder and look at this file right here. And just as a quick overview of what's happening, we're doing some validation just to make sure we're receiving a proper input. And then after that, what we're doing is unmarshalling the record that we received. Basically, whenever you receive something from the DynamoDB stream, it's kind of packaged funny, and we want to unmarshal it and put it back to a JSON object so we can handle it. After that, we want to package everything up and send it over to our screenshot function. So this is kind of where earlier in our Python script, we were talking about the URL, the destination path where we want to save our files, and the author ID of whoever created the tweet. This is where all that data is getting saved. And we're actually passing it over to our API Gateway screenshot endpoint. So that's what we're going to focus on building next, our screenshot API endpoint. But yeah, that's how that function works. So let's go ahead and do what we normally do and hop back over to the proper directory. This is inside the tweet commit DynamoDB folder. Great, now that we're in here, do what we normally do, npm install. So we have all our dependencies in our node modules. After that, we're going to do the usual, npm run zip everything up, and then finally npm run deploy. And before I run that, I'm just going to check real fast just to make sure we're pointing to the right endpoint. Hop over here, and glad I did that because we definitely are pointing to the wrong function name. So let's head back into our console real fast, scroll up. I'm going to copy this, and now I'm going to run deploy. And now that this is finished deploying, I'm going to head back to our Amazon console, go to our functions. This was the last function we just edited. All right, now when we look inside, it should have all of our code. Okay, cool, fantastic. So let's head over next and update this API Gateway endpoint. In order to do that, let's head over to our services and click API Gateway, open it in a new tab. We've been working on this gateway endpoint the whole time. So what we're gonna do now is just like what we've done every other time, create a resource. We're gonna call this one screenshot. And the reason we're calling this one screenshot is because if you go back over to our index file, you can see that we're going to be sending everything to this screenshot endpoint right here. Great, now we'll press create resource. Now under our screenshot endpoint, we need to add a specific method to enable for us to post. So I'm going to click that, confirm it, and then now it's going to ask us to link to a specific Lambda function. And I actually made a slight error earlier where we need to start pointing to different Lambda functions. So this one specifically needs to point to our tweet commit screenshot request Lambda function. And we need to actually go back and update our milestones Lambda function endpoint. So this is also pointing to the screenshot endpoint. That's incorrect. We actually need to make an entirely new Lambda function. So let's do that really fast. We'll hop back over to our Lambda functions, click to Lambda. We're going to create a new function. We're going to call this one tweet commit milestone. It's going to be a JavaScript one. We're going to leave it how it is. Okay, so let's head back over to Visual Studio Code, and we need to be looking at the index file inside this tweet milestone. This is basically just an endpoint for our web client. All it's going to do is we're going to send up a milestone ID. It's going to make a fetch request to our DynamoDB table. It's going to see if it exists, and it will return our milestone data back to our user with a status code of 200 and show all of the different tweets per date. So that's all it does. So we're gonna do what we normally do. We're gonna do cd, head over to this proper Lambda function, enter. We're gonna do what we normally do, install everything. We need to make sure that our package.json is pointing to the right spot. In our case, it isn't. So let's copy this and head back. I'm going to update this, save it. And now whenever I run npm run zip, we'll zip all of our stuff up, and then npm run deploy to deploy our code to our Lambda function. So as you can see, it's empty right now except for our basic stuff. What you'll see is that the function has now been updated with all the code that we just showed. So now all we have to do is update this milestone endpoint. So I'm actually going to delete this post request real fast, and then I'm going to come back in and recreate it. Create method, post, except this time the post needs to be pointing to our tweet commit milestone Lambda function that we just created. Fantastic. We're going to save it, and it's going to add the proper. All right, fantastic. And I know I've hopped around, so let's just see exactly what we've done. We've made it to where we have our screenshot request Lambda function. We have that working. We added our new gateway endpoint. We also made it to where our website can actually do an API call to our DynamoDB table. That was that milestone. That was that tweet milestone API endpoint that we created. So the very last two things we have to do is make this Lambda function right here and make this bucket. So let's hop back over to our Amazon console and start creating our S3 bucket. Okay, so we're gonna head back over to our Amazon console real fast, click our S3 bucket. And now that we're inside of our S3 bucket, we want to make a new one. So we're gonna click this button right here. We're gonna call this our tweet commit S3 bucket. I'm gonna scroll down to the bottom. I'm going to uncheck our block all public access. That's just because I want us to be able to easily fetch the different objects that we store in our bucket. Scroll down all the way to the bottom and then press create a bucket. This usually takes a few seconds to create, but what we need to do next is change the properties and permissions of this bucket so that it actually is public. In order to make that change, you're gonna need to click the bucket, and then you're gonna go to permissions and scroll all the way down to the bottom of the page and go to your bucket policy. Once you're in your bucket policy, you're gonna wanna press this edit button right here, and then you're gonna wanna paste the code that I have on the screen right now. Basically what it's saying is what version of a policy are we using and what do you want to allow? So in our case, we want to allow anybody to grab any object inside of a resource. In our case, our resource is going to be our tweet commit -s3 bucket. Fantastic. So then we're going to save our changes. And then now you'll notice that it says this entire bucket is publicly accessible. Cool, so now we just need to go back and update our Lambda functions to point to this specific bucket. All right, so what we need to do in Visual Studio Code is go over to our code.py file, which is inside of our tweet commit screenshot folder. So I'm gonna open that up real fast. And what we need to do is update the bucket name to match what we wrote earlier. So as you can see, tweet commit -s3, same thing right here. And then once we do that and save the file, we're going to have to make sure we're in the right directory, which we are, tweet commit screenshot, tweet commit screenshot. And then because this is a Python file, we're gonna have to run our deploy.sh file. Just in case, to recap what's going on, we're going to zip it, and then we're going to deploy it to AWS. So I'm just gonna run it real fast. Cool, so it'll zip everything up, and then after it zips everything up, it'll send it back up to our Lambda function. Fantastic, everything worked properly. So let's head back over to Visual Studio Code, and what we need to do is create our final Lambda function. This Lambda function is going to be the one that actually sends a DM to our user with a picture of the screenshot that we just saved to our S3 bucket. So in order to do this, we need to go ahead and click this create function over here. For this function, we once again need to change the runtime to be Python 3.7, and the reason we're going to do this is because we're going to take advantage of the tweetp library, which is a Python specific library to interface with the Twitter API. We're going to call the name of this function tweet commit -image DMer. Scroll down to the bottom and press create function. And once this function finishes deploying, we're gonna head back over to Visual Studio Code. Okay, so when you're back in Visual Studio Code, the main thing that you're going to do is open up the tweet commit image DMer folder. And the first thing we're gonna look at is this installer.sh file. What this is gonna do is install all of our packages inside a package folder. So we're gonna make sure we're first off in the right directory, and I've already changed to it. And then you're gonna change the permissions of this file by doing changemod +x installer, save it, and then you're going to run your installer, and this will actually install all of our packages. and it'll create a new folder for us over here. Fantastic. So we can close out of this. And then now I'm going to walk you through what's actually happening inside of this Lambda function. So what we're going to configure in just a few seconds is an S3 stream. So whenever a new event is, so what we're going to configure here in a few seconds is an S3 stream. So whenever a new item is added to our S3 bucket, it's going to trigger this Lambda function right here. Whenever this Lambda function is triggered, the event context is actually going to let us know exactly which record was updated inside the S3 bucket. So what we're going to do is pull out the bucket, and then what we're going to do is pull out the key of the ID that was created. This key specifically has the ID of the milestone picture, and it also has the author ID. The author ID is important because that's what we're going to use to DM the person who we need. So the author ID is important because that's how we're going. So that author ID is important because we need to know who we have to send this DM to. So once we pull out that information, what we're going to do is actually pull down the S3 object using our bucket and key, and we're going to download this image to our temporary temp folder. But in order to do that, we have to call this function right here and pass in the parameters that we just set up. And next, once we've downloaded that image, we need to start working with the TweeP library. In our case, what we're doing is we're generating. So what you see that we're doing is we're authenticating. So what you can see is we're authenticating access to the Twitter API. So what you can see is we're working with the TweeP API. So what you can see is we're using TweeP to authenticate ourselves with the Twitter API and creating a new API handler. In order for this to properly work, what we'll need to do is go over to our folder and add our environment variables. So we're going to do .env, and what we need to do is copy and paste our consumer token, consumer secret, access token, and access token secret. So I'm going to go ahead and do that really quickly. When you're done with it, yours should look just like this, where you have your consumer token, consumer secret, access token, and access token secret. Except yours won't have X's, yours will actually have your appropriate keys from the Twitter API. All right, let's hop back over to our Lambda function. So there's one big special thing that we have to do in our case because we want to send a picture, and that's we have to point to the media that we want to upload. Thankfully, since we've already downloaded everything from our S3 bucket, we can just point to our download path, which was right here. And then we can set our recipient ID to be our author ID. And thankfully, we were able to pull that out earlier. And now what we can do is say, hey, TweeP, I want to send a direct message to this recipient. I want you to include this text, and I also want you to include this message. Okay, cool. And then when it's done, it'll actually just send a direct message to the person. So there's one final step that we have to do for all of this to work, and that was to set up our S3 stream. So let's go ahead and do that, and then we'll finally show you how everything works all together. So let's head over to our Amazon S3 bucket real fast. Okay, great. Now that we're here, we're going to click on our S3 bucket, wait for it to load, and then we're going to be clicking the bucket that we're working with. And the first thing that we're going to need to do is click on properties, and we need to enable bucket versioning. This is going to allow us to work with streams. So we're going to save changes, and then I'm going to scroll down to the bottom of the page to click on this event notifications part. So I'm going to do create event notification, and I'm going to call mine new image. I'm going to scroll down to say that we only want to worry with object creations on a put request. I'm going to scroll down even more. I think we can ignore pretty much all of this. Yep, we could ignore it. And then we have to say which function we would like to use. So when we click in here, you can see that we want to work with a tweet commit image DMer. So I'm gonna click that, I'm gonna save changes, and it might give us some errors. Nope, it worked properly. Okay, cool. So now each time a new image is created in our S3 bucket, it will send that object along to our tweet commit image DMer button. All right, so that was the very last step in this tutorial, and I hope you enjoyed it. If you have any questions or got stuck at anywhere, just drop a comment down below or shoot me a DM on Twitter and I will happily help. But I have a lot more tutorials on this channel that I think you would enjoy, so feel free to check those out. And if you got some value from this tutorial, please hit that like button and that subscribe button. That would really help out my channel. So yeah, with that said, I hope you have a great day and thank you for coming by.